honestly. Who remembers how we need to think about start with the reflection? You're doing a reflection. Tell me what you're doing. Tell me in English what's happening if you have a reflection. Yeah, you're doing a flip over a line, over an axis, something like that. Next thing we talked about is a rotation. How's a good way to think about a rotation? Yeah, sort of a turn. It's going to have sort of a fixed pivot point on it, but you're turning with one point into the center. Most times we assume it's 0, 0, but it's not always. Translations we talked about 2 classes ago. How can we think about a translation? Yeah, it slides it around. So maybe even at the top, I'd make sure I had all that going to start. We talked about rotations. And rotations should kind of mean that you're just turning or rotating the figure. We talked about a reflection. The lazy language on that, or easy way to conceptualize it, is to think of it as a flip over a line or an axis. We talked about a translation, which the easy way to think of that is as a slide. You're literally taking the same figure, moving it around, not even rotating it at all. We also talked about a dilation. And what does a dilation do to your figure? Yeah, it's sort of, it's, I guess, a shrink or an expand. It doesn't change the angles, it does change the size. One other thing also that we have talked about in the past, it's not necessarily part of this unit, is we've done out all of these so far, hopefully not too bad. We're going to talk today about what happens when all of them get done together. Here's the main thing that we are going to discuss. Right? Brought up this isn't what we use anymore, but use to show you out what's going on for today's stuff. Let's talk about right now, that's my original figure. So if that's my original figure, what we're talking about today, I think it says it right on it, it's called glide reflection. Is that right? Okay. It literally means it's a transformation where you're gliding a figure after a reflection. So let's just say I'm going to reflect this figure over the x-axis, which is right, the x-axis, which is right here. Now when I reflect that figure over the x-axis, I would get something kind of like, so if I did a reflection, it would kind of look like that. That's only the reflection part. The other thing is called, what was the word in front of the reflection? Right. So that is where it needs to be reflected. Okay? So first step would be to reflect it over some line, and then it would slide somewhere along this line that it reflected along. Okay? So in order to make that slide happen, normally I say the reflection is a reflection. And what do we need to do to slide our figure around? What math operation do you think? You really should have written it out as 37 on the top corner. The paper, what did we refer to? Yeah, it's a translation. That's what the slide is talking about. So this figure has us doing a reflection and then a slide back and forth. That's it. And that's all the stuff we're talking about today. If it does that and it slides parallel to the line that you're reflecting over, then it's a slide reflection. If it doesn't, then it's not. And that's pretty much it. There's not much more. If we have a dilation, that's probably not going to be a glide reflection because that's bigger than the one that we had before. It's more than a flip and sliding this way. They're not congruent figures. It just needs to be the same. flip it over, and then slide it somewhere along that axis. That's what we're going to go through and try to see if that's happening today. So, on your notes, I went to page 23. The coordinates of that triangle are shown. So first thing up, go in and sketch out triangle GLD. We're going to do these all the way out. You need some sort of straight edge. You use the size of your calculator if you need it. So to begin, I'm going to plot out those 3 points. L is over 6, down 4, L, and then D is 3, -1. So right now I go through and connect and make the triangle. Next thing that it says, draw and label the double prime triangle after that composition of functions. So that means I'm going to do 2 different things. Which of those 2 would need to get done first? Look at your paper. Which of those 2 operators in 1A, Caleb, would we go through and do first? Reflection over what? Okay, so I'm going to make a reflection over the x-axis, which means, by the way, I'm going to be getting G prime, L prime, and D prime. So let's go and make that happen. G prime reflected over, and what's G prime? Jason going to have a good coordinate. Good, so over 1, up 5. And that would be G prime. Make sure you label it accordingly. Marlene, which other point do you want to give? Okay, what's the coordinate on L prime going to be? Perfect, go over 6, up 4, and label that with L prime. And then our next one, Mitchell, what's D prime going to be? Okay, go over 3, up 1, and that's D prime. And I'm going to label. And just so we're clear, we reflected this over the x-axis, right? I'm going to highlight the x-axis on mine so you can see. You don't necessarily need to do that on yours. But I'm highlighting what I'm reflecting over right now so I can see. Hopefully it'll make it a little bit easier to see if that's a line as well. So we did the reflection part, and now what else is it telling us to do? And let's list out our points. But David, what is it telling us to do after I list out the line? After I list out the reflection? Yeah, and I'm going to just list out those points. We said that this was 1, 5, G was 6, 4, and D was 3, 1. And then we need the double prime. So G double prime, we're going to go through and, like you said, subtract 8, add 0. Chris, what's G double prime going to have as its coordinate? -75 is right. Tyler, what are you going to say for L double prime? Good. And then after that, D double prime. Zach, D, what was that? -5 what? No. What are you doing to the rival? So when I graph that out, I just slid all those points 8 over. So it kind of looks -7, +5. That would be G double prime. Here. As you go through and look at this, do we have any questions, I guess, on how to do the transformation, right? A to C, is this a glide? Yes or no? Why? Here's an easy way to check. You did your reflection, and then the translation that we did moved us from D prime to D double prime, or L prime to L double prime, or G prime to G double prime. Look at all of those, any of those last vectors that we just showed to show the translation, and compare those to the line that you reflected over. What do you notice about it? Perfect. If they're parallel, you have a glide reflection. Were these parallel? Yes or no? Do they have the same slope? Sure. So, if it goes through and ask, is this a glide reflection? You go through and say yes. And there's a bunch of reasons that we could go through and say, but we translate along. Now, I guess, I don't know, let's do G prime to G double prime. And that is parallel to the x-axis that we did our reflection line in first. So you're going to compare your line of reflection and see if that's parallel to the type of translation or slide that you go through and do after the reflection. That's it. And by the way, does the figure change size or shape when we do our glide translation? Is it a different size triangle? Yes or no? The answer hopefully is a no. All right, hopefully that's enough to that. Let's try one more like this. Looks like we got too much bad to go through and do today. Try out right now, number 2. Go through right now and try out number 2. Start off and graph triangle PQR. See where this takes you. So hopefully you can at least get the first 3 done. You're going to take and do that translation first. Madison, what would you get as the coordinates after you do the translation? Great. There's 1, -2, and the other was 1, 0. Okay. So I'm going to go through and graph that out and make sure I sort of label it so I know what I'm doing. This was -1, -2, and that would be 2 prime. 2 prime is 1, -2, so that's over 1, 2, 3, 5, and R prime is 0. That's fine. And now, after I do that, I'm going to reflect it over the line, y equals x. So, Aubrey, what do you think C double prime would be? The image of C after the y equals x reflection. Okay, can we keep going? Good. So now we're going to graph those. I'll do those. Now if I do this, yeah. Yeah. And just so you were clear, you reflected it over the diagonal line y equals x. You would very likely show that on your paper, so you can tell if in fact it is a glide reflection, and therefore parallel to the line that is reflecting over. So, given this out, the line y equals x, and then it extends forever that way also. How can we check to see if this in fact is a glide reflection? Well, look at the reflection, and then go through and compare it to the original. Which one is the one after the reflection? Green one. Isn't this what we ended up? Yes or no? Okay, and then this, we went from here to here. What do we notice about all those vectors if we were to sketch them out? How do they compare to our line of reflection? They're parallel. If they're parallel, do we have a glide reflection or just a regular reflection? Which one? It's going to be a glide reflection, yes. So we would go in and say, is this a glide reflection? We say yes. And pick any of those vectors that connect the 2 points. So if I'm looking at this, we could pick any 2 that we want. I don't know, let's see, P to P prime. So P to P prime. And how does that compare to our line, or our reflection line? We can just say our vector, our slide from P to P prime, that motion is parallel to the line y equals x. And was that the case? Yes or no? I'm looking at that right now. All of this motion, was it parallel to the line that you're reflecting over? Is that tough to do? We might do one more of these. Slide over then to our next group, which is going to, our next one is going to talk about centers of dilation. And we talked about that a little bit before. What page number is it? 27. All right. When we're talking about going in and having a dilation that's not centered at the origin, the same rules go through and apply. You just take the distance from the point that you're dilating based on, your center of dilation, and count to all of the individual points on the original. And then, like before, if you went over 1 and up 3, and you're dilating by a scale factor of 2, now instead of going over 1 and up 3, you go over. Just take whatever that motion is that you did before, and double it. That's it. That's all we're asking you to go through and do. We've got a state of transformation here that's going to map A, B, C, which is this guy here. The original, and here's what we get at the end. So that dilation that gets us from A to B to C to A prime, B prime, C prime, we've got to go through and figure out, is that a shrink or an enlargement? Which one? It's an enlargement. So our dilation factor, what do we know about it? We don't know its number value, but what do we know about whatever it is? And just an enlargement. It's going to be positive. It can't just be any positive. We know something about it. What happens if it's less than 1, like 0.5 or 1/3? It'll shrink down. Does this shrink or get bigger? Get bigger. The way you find out how much bigger it would be when you would take the old side, sorry, the bigger side, I guess, the transform side, and compare it to the original one. So in this case, you could go through. We need to identify the transformation. Well, we say it's a dilation. The only thing we don't know about it is what the scale factor would be. So, because there's no numbers, if you're trying to figure out what it is, take any of the new segments over the old ones. So you could take, I don't know, how about A prime, C prime over what other segment? That's the new one. What's the original? That would match up with that if you're trying to figure out what you have to multiply by to make it bigger. Take 2, yeah. Or you could use what else? You can give me another way we could figure out our scale factors. A prime C prime over AC, the long segment over the short one. What other options do we have? What? Which would be this segment here, A prime, B prime, the long segment over this short one. What else could we go through and do? What's our third option? Perfect. All of those, when divided out and reduced, should be equal or congruent. The only other thing that's a little bit awkward to go through and do is if you're trying to find the center of the dilation and it's sort of stuck between 2 points, what you do is you start finding a point of concurrency, which just means a meetup between all of the points, I guess the edges of the points if you were to extend them out. Remember how before we talked about flag rotation, drawing out that vector, and you start at one and end at another? We're actually just going to draw some long lines now. So let's start with this. How many of us have a straight edge at our desk? Maybe you have a compass or a side of the ruler. Compass or the side of your calculator. Use that as a ruler. Some straight edge. If you have one that you'd like to use, decide to just have it out. Doesn't matter what you do. We're going to figure out what our transformation would be to take A, B, C and make it A prime, B prime, C prime. Now, if I were going to try to figure out the transformation that performs it, well, is that a dilation? Okay. Are we equal? No. So we had to have a dilation somewhere in there. The only problem is we need to figure out how big and where did our dilation start from. Go in right now, take your straight edge, and see, put a point, I guess, at A so you can clearly see the point at A prime. And I want you to sketch out, use your side of your calculator if you've got it. Use some long straight edge. Your task is going to be extend that out. Very lightly, don't draw like this on therapy where you lightly, give yourself sort of line connecting. Now let's do the same thing from C to C prime. Kind of look like this, and then B and B prime, trace that back. And if we did this correctly, if we did this the right way, does everything come together at a common point outside of it? That's your center of dilation. So you just went through and made that happen. Now we're trying to figure out the center of dilation is there. Let's name that point maybe. We got A, B, and C here. How about L? How's that? Some random point L. How do I go from A, B, C to A prime, B prime, C prime? Well, what type of transformation did we say this was already? It should work out to be a dilation. Centered at or based out of what point? Yeah, point L. Do we have a coordinate for L? No. And what is our scale factor? Well, we don't have numbers, so who can help us out? There's 3 possible scale factors you could list. What would one of those, just one of those 3 possible scale factors be? We got one person. Go back and look. We'll just see what we did before. 2 of us. Jackie, what do you say? What else could we go through and say besides A prime, B prime, and so on. What else could we say? Yeah, any of those work. B prime, C prime over B, C. Do we have questions on that part? Next one up. If we go through and we're dilating, let's say that. Take a look at question number 3. I think that you're good enough to do this on your own right now. Take a look at what's there. What are the coordinates of B prime, C prime after segment BC undergoes a dilation centered at point A with a scale factor of 2. You were okay with dilating when the center was the origin. The process this time will be exactly the same, except instead of doing your counts from the origin, you're going to start your counting at what point? Okay, so give it a try. Before we become explained by rules and things like that, give it a try. Okay, fail on yourself. I don't know what to do. Try something. Not knowing what to do is a little concerning. You've got to try something. With that something in it. Right? From the point, okay, this is done pretty quickly. You can tell me what they think B prime would end up being. You can tell me what they think the coordinate of B prime would end up being. What's our scale factor that we're dilating by? 2. So let's count from A to B. So to go from A to B, I have to go to the right one and down one. I'm going to dilate by a scale factor of 2. So how am I going to get to B prime? We double the distance to B. So I went to the right one and down one. What do you think I'm going to have to do if I double those distances? Yeah. Well, I'm going to have to do something before I go down 2 more. Literally went over 1 and down 1, right? So when I dilate this by 2, how many am I going to have to go over? I mean, 1 more if you want. From A, I go over 2 and then go down 2. Or if you were saying repeat that as a second motion, that's fine also. It's the same point. What would this ordered pair then be? What would that coordinate be? Yep. 1, 2, 3, 4, count over 5. And then we go up 2. Now do the same thing, the exact same process, to get what C prime would be. And Sam, did you get what C prime would end up being? So, 1, -3. Okay, 1, -2. The way that you would get this, I start off at A. I go back 1, down 3. I'm going to dilate that by a scale factor of, it was 2, right? Yes. So now instead of going back 1 and down 3, I'm going to go back how many? 2 and down how many? 6. So I go back 2 and down 6. Back 2, down, that was 3, 4, 5, 6. Puts us there. That's C prime. And that coordinate, I think we just said was what? 1, -2. Here's the segment. Connect those points. You're done. And by the way, what do you know about the length of segment BC? Sorry, B prime, C prime? How much longer than the original? Double. Yeah, because it's a scale factor of 2. That's it. Questions on that one? Let's give the one to the right of it a try. You've got 2 points, 2, 0, and 0, 4. Scale factor of 1/2 centered at the point 4, 2, -4, 2. So let's go over -4, 2. We're going to go back 4, 1, 2, 3, 4, up 2. -4, 2. That's my center of dilation. And then we know point A is the point negative 2, 0. So I go back 2 and up 0, that's A. And we know B is over 0 up 4, 1, 2, 3, 4. That's B. You can connect them if you want. We're going to dilate that by a scale factor of 1/2. So, and which point do you want to travel to first? A or B? Okay? To get to A, you go down how many? And over how many? So now you're going to dilate by a scale factor of 1/2. So how many are you going to go down? What did I thought it was? What did I mention? This point here is wrong? Oh, and what's going to be? Negative 4, 2? Oh, I just, okay, sorry. So it should be, according to what you were saying, then how much should the movement down be? And? Okay, so what did that, and maybe some of you started freaking out. Why would it cause you to freak out? What would you have been arriving at? Okay. Right? Wouldn't that put us between 2 points? You still could have gotten it. My point would have been off, but we could have used the change. So how far over am I going to go to get to A prime? If I went down to over 2 with the scale factor. If you ran 2 miles yesterday and you ran half that amount today, how many miles would you have run? So I'm going to go, instead of going down 2 and back 2, I'm going to go down 1 and back 1. And that's our new A prime. Now let's do the same motion for B prime. Normally I would go up. How many are we going up to? 2 and back 4. Is that right? So now instead of going up 2 and back 4, and what am I going to do to get what B prime would be? What would that B prime coordinate be? Yeah. Do we have questions on that? Hopefully it's not that bad for us. Take a minute then and do that. Yeah, let's talk about how we would get our set that guy over to the side. Last time that we had class, you guys went through and did the dilations which one that was like this, is that right? Okay. We're going to go through today and do one on reflections. What we have you do is, can you get these into your vocal cords? And we'll have us come back together in about 6 or 7 minutes. I will tell you this before you get started. One thing on here that's a little bit awkward. 1, 2, 3, 4, 5. The points on here, the scale, you're probably, if you go through and draw out your X and Y axes, you're going to want to use a scale of 2. You're going to want to probably use a scale factor of 2. Okay? When you're giving out your axes, use a scale of 2, otherwise you might not fit on that. Let's do this. Once I go over the and let's do that. Actually, why don't we have you stay and let's have you right here. Go you 3 stay here. Okay? You guys can just move yourselves over to the second. You got to sketch those in. I'd advise you just in general, A scale factor of 2 might be good. I'm trying to see if we can get